Hi there, this is Weblan. Welcome back. Remember to subscribe. We are continuing with our number patterns. In the previous video, we dealt with a linear number pattern with the general term Tn is equal to Bn plus C. This is a linear number pattern. And then we go to a quadratic number pattern. Tn is equal to An squared plus Bn plus C. You should remember this from your algebra. This is the standard form of a quadratic equation. When you are dealing with equations, we'll be calling it ax squared plus bx plus c. We also deal with it in functions. F of x is equal to ax squared plus bx plus c. That's a quadratic function. So when you are dealing with these quadratic number patterns, you should also remember that what you are dealing with is the same as what you have dealt with in functions, right? So sometimes you even use your knowledge of functions to deal with problems in quadratic number patterns. All right. Our T1, if we substitute 1 for n here, T1 will be A plus B plus C. T2, in place of n, we put a 2, we will have 4A plus 2B plus C. And the third term, when n is 3, we put 3 in place of n, we'll have 9A plus 3B plus C. The same goes with term 4. And then I've written the terms here as a number pattern, T1, T2, T3, and T4. And the difference is here. To find the first difference here, we are saying T2 minus T1. So 4A minus A is 3A. 2B minus B is B. C minus C is a 0. 9A minus 4A, this is 5A. 3B minus 2B is B. C minus C is a 0. 16A minus 9A is 7A. 4B minus 3B is a B. C minus C is a 0. And then we look for the second difference. 5A minus 3A is 2A, B minus B is 0, and then 7A minus 5A is a 2A, B minus B is a 0 there. All right, now this is what I want you to notice. 3, 7, 13, 21, and it continues on and on like that. We do the same process that we did when we were dealing with linear number patterns. Look for the differences. You'll notice that the first line of difference is not constant, but it is giving us a linear number pattern, 4, 6, 8. And then look for differences for this one. This is now constant. It means we have a constant difference here, that is 2. It's not always 2. It depends on the number pattern. With this one, it is 2. And then the first line of difference, okay, the second line of difference, we have a 2 here. And then the first line of difference, we have a linear pattern. It means this is a quadratic number pattern. So if you are asked to show that this is a quadratic number pattern, you just show that by determining the differences. If the first line of difference is not constant, if it is a linear number pattern, it means this is a quadratic number pattern. And then when we are determining the general term, we should know that this one is equal to 2A, because we have a 2A here. This is where the 2A is coming from. And then this one is 3A plus B is equal to the first term in the first line of difference. This is because when we dealt with this one, this is 3A plus B. They are on the same position, right? And then when you are determining the value of C, it's a plus b plus c is equal to the first term, because here the first term is a plus b plus c. You don't have to remember this whole thing in your head, but you just have to remember that 2a is equal to the value that we get on the second line of differences, and then 3a plus b is equal to this 4, and then a plus b plus c is equal to this one. This is all you are supposed to remember if you are determining the general term of a quadratic number pattern. If you want to see how to do this, how to determine the general term of this number pattern, check my next video. Enjoy.